My name is Sarah Leon.
My name is Lonnie Cravens.
And I'm Audrich Finn, and we're 7th graders from Dalton Middle School. Do you know somebody that is deaf or hard of hearing?
If so, a cost-efficient solution might be the one for you.
On average, hearing aids cost around $7,000, to comparison to our $200 solution. This is
The
VibroBand.
The VibroBand is an electronic device for deaf and hard of hearing people. The band is placed inside and somewhere on the arm, and when sound is sensed, it converts into vibrations. The idea of the VibroBand came from one of our partners' family members and their fire alarm. The fire alarm went off in their house, and they weren't able to hear for obvious reasons. To fix this problem, we could have put a light on the fire alarm, but we wanted to make something that could go anywhere.
The materials we mainly used for this project was an Arduino Nano, which is Arduino's friendly design and known for its small dimensions, an Xbox Rumble, which is a haptic feedback that is generated by 2 independent motors, and an expansion board that, when connected to a computer, it provides extra facilities or memories. These are all the main parts we use for this project.
To start out this project, first you have to connect the Arduino Nano to the expansion board. Then you have to wire different components like the sound sensor, vibration module, power supply, and IC chip to the breadboard and the Arduino Nano. To follow out with this, you have to follow the given schematic for the wiring. Now, to put in the code, you have to type in the code given to Arduino Nano IDE. Then you have to export your code into your Arduino Nano.
Our project had a total of 3 prototypes. The first prototype was unsuccessful because of an error in the code, also known as the XCS status 1. The code is a main part in our project because it controls on what our project actually does. In addition to not only an error in the code, was also an error in our vibration module. It went on for too long and was too strong.
The second prototype didn't work either. This was because although the code was successful, we had problems with the sound sensor module. The sound sensor module was set too low, causing the sound waves to not be detected. This then led to the vibration module not running. Other problems we had was the design for a prototype, as it was unpresentable and messy.
In our third and final prototype, everything mechanically worked in our favor. We were able to hit all the points that we wanted to hit. We did this by rewriting our code and following the schematic to assure that our wiring was correct. One thing that we changed about this prototype is how messy it looks. On the outside, it looks presentable and unmessy. When you go on the inside and the wiring, it is messy and it is unpresentable.
This is our final prototype.
The prototype is tied around a participant's arm, double knotted, and inside we have the breadboard, the Arduino Nano, the sound sensor, and underneath the cardboard is our vibration module. We have concluded that our VibroBand works well enough to serve its purpose.
Other things we noticed was that to have a good design, we needed to make multiple changes. For example, the code and the multiple components had to be changed to make the design more efficient. Also, the original design of the VibroBand had to be changed for it to be more comfortable to the participant. Our data shows that we made our proposed solution work because people who are hard of hearing are able to detect sound with vibrations.
Thank you for listening. This is our project on
The VibroBand.